What if the closest place we could ever call home is already whispering back to us, and we just can't hear it yet? The stars don't speak in human tongues, but they do echo. For over 100 years, Earth has sent radio signals, accidental cries of our presence into the cosmic abyss. These invisible waves, born from humanity's first crackling radios and wartime broadcasts, have already reached dozens of nearby stars. They've touched Arcturus, they've brushed past Aldebaran, and among the most intimate of cosmic neighbors now listening is Alpha Centauri. Please like and subscribe, because this journey will change how you see our place in the universe. Prepare yourselves. We begin. Alpha Centauri isn't just a star, it's a triad of suns, a gravitationally bound dance between three celestial bodies, spinning in elegant precision, just 4.36 light-years away. And yet, despite this proximity, it's as unreachable as a dream. Our fastest probes would take tens of thousands of years to get there. Light does the trip in 4. We haven't even taken 1. Still, our eyes are on it. Our hopes drift toward it, because Alpha Centauri is more than just our neighbor. It might be our first step into the infinite beyond. The main duo, Alpha Centauri A and B, shimmer together in our night sky as a single point of light. Through a telescope, they resolve into 2 bright stars, dancing around a shared center of gravity like cosmic partners locked in an 80-year waltz. One is a yellow sun, slightly larger than our own. The other, a smaller orange sibling, flickers with unpredictable flares and quiet eruptions, bursts of energy that could sterilize any nearby world. We've scanned them for exoplanets, scoured their neighborhoods, hoped desperately for whispers of Earth-like companions. So far, nothing confirmed. Just ghosts, data anomalies that hint, promise, retreat. But a planet-sized shadow near Alpha Centauri A has teased us. It could be 9 times Earth's mass, or 35. It could be real, or it could be noise. Alpha Centauri B, the more volatile sibling, once sparked immense excitement in 2012. Astronomers thought they saw a world, hugging the star in a rapid 12-day orbit. But it was a mirage, a mathematical error, a dream shattered by corrected data. This is the heartbreak of astronomy, to see a phantom world and then watch it dissolve. But the most poetic part of this trinity lies even closer to us than its siblings. A small, dim, almost invisible star, Proxima Centauri. Its very name means closest, and true to its title, it's the nearest star to our Sun, currently just 4.25 light-years away and inching ever closer. In another 26,000 years, it will be only 3 light-years distant, a cosmic blink from our doorstep. Proxima is a red dwarf, barely burning, cool and quiet compared to its flashier companions. You can't see it with the naked eye, but it might host the most important planet we've ever discovered. Proxima Centauri B, a rocky world, orbiting within the habitable zone. Let that sink in. A potential second Earth just next door on the galactic scale. But proximity is not promise. Proxima B is lashed by radiation, baked and battered by stellar flares. It clings close to its faint star, orbiting every 11 Earth days. Likely tidally locked, it always shows the same face to its sun, a scorched, frozen duality. One hemisphere in eternal fire, the other, eternal night. Still, scientists believe it could harbor liquid water, maybe in the twilight band where day meets night, maybe shielded beneath thick clouds, maybe not at all. A dense atmosphere could temper the extremes. A magnetic field might shield it from death by solar rage. But we don't know. We won't know until we go. And we are trying. One day, we might send breakthrough Starshot, a fleet of microscopic ships, pushed by Earth-based lasers, riding the wind of light at 20% the speed of light itself. These thumb-sized probes could reach Proxima in just 20 years, add 5 more to beam back their data. In a single human lifetime, we might finally look at another star system not as astronomers, but as visitors. It would be a transformation, a new chapter, not in science fiction, but in reality. Proxima doesn't host just one world, it might hold three. In 2020, scientists confirmed a second planet, Proxima Centauri C, a colder, more distant super-Earth, possibly encircled by rings 5 times wider than Jupiter's. It orbits every 5 years and may resemble a mini Neptune alien, icy, waiting. A third, even smaller planet may also lurk nearby, skimming just 0.029 AU from its star, closer than Mercury is to our Sunday. If it exists, it could be a scorched pebble, spinning through hellish heat. Each of these worlds is more than a point of data. They are cosmic invitations, questions flung into the void. Can life exist there? Could we survive there? Will we ever stand there, looking up at our sun from another sky? But here's the thing. For over a century, Alpha Centauri has been quietly absorbing our broadcasts, our television shows, our songs, our declarations of war, our cries of love. It's as if we've been sending a bottle into the sea of stars every second of every day, and now, maybe someone or something is listening. Yet we remain marooned, brilliant, isolated, speaking into a silence that never answers. This is the paradox. The closest star system, the most reachable planets, are still impossibly far. Alpha Centauri is a mirror. It shows us who we are: hopeful, restless, dreaming apes perched on a pale blue dot, flinging signals into the cosmos and daring to imagine an answer. Maybe one day we'll go. Maybe one day we'll hear a voice call back. Until then, we look, we dream, we send tiny whispers across the abyss, and we wait. Not all stars blaze with glory. Some simply drift old, cold, and forgotten, carrying the wisdom of 10 billion years in their silence. What if the future is rushing toward us? 6 light years from Earth, hidden in the ink-black sky, moves a faint red ember so dim it cannot be seen without a telescope. Yet it barrels toward us like a ghost ship emerging from the cosmic fog. Its name? Barnard's star, the quiet runner, the stellar loner, and one of the oldest objects in our galactic neighborhood. It's not impressive at first glance. No brilliant flare, no dazzling rings, no planetary dance visible to the naked eye. But that is a deception, for this single point of light may hold more history and more possibility than most stars will ever know. Discovered in the early 20th century, Barnard's star gained its reputation not through brightness, but motion. It zips across the sky with a proper motion, faster than any other known star, like a whispering arrow piercing the void. Within 10,000 years, it will become our closest stellar neighbor, overtaking even Proxima Centauri in a silent race few knew was being run. But its true story began far earlier. This ancient red dwarf is estimated to be over 10 billion years old, more than twice the age of our Sunday. It has burned slowly, steadily, like a candle made to last forever. In a cosmos defined by chaos, explosion, and decay, Barnard's star is constancy, patience, a reminder that not all things must end quickly to matter greatly. Its mass is a mere 17% of the Sun's. Its light, 2,300 times fainter. Its surface simmers at just 3,134 Kelvin. Compared to the violent infernos of massive stars, it is gentle, a cosmic ember, not a bonfire. And yet, even embers can harbor life. In 2018, after 2 decades of obsessive observation, scientists spotted something extraordinary: subtle gravitational wobbles, rhythms in the motion of the star, a planetary heartbeat. They called it Barnard's star B, a super-Earth, at least 3.2 times the mass of our world. It orbits every 233 days at a distance of 0.4 AU, closer than Venus lies to our Sunday. But that's where the similarities end. Because Barnard's star is so dim, this exoplanet receives 50 times less energy than Earth. Its average surface temperature? A glacial negative 168 degrees Celsius, colder than the deepest Antarctic winter, frozen in silence. lifeless by all conventional accounts. But the universe is rarely conventional. Beneath that icy surface, something extraordinary may lurk, a hidden ocean, warmed from within by radioactive decay or tidal forces, trapped under kilometers of ice, sealed away from the stars. A world not lit by sunshine, but by its own internal glow. If such an ocean exists, it has had billions of years to evolve undisturbed. 10 billion years. Imagine what could bloom in the darkness given that much time. Life doesn't need sunlight, it needs complexity, chemistry, time, and Barnard's star has all three. It's strange to think that such an ancient world, colder than Pluto, darker than midnight, older than history, might hold secrets more vital to us than all the golden planets basking in their star's warmth. Why? Because it challenges everything we thought we knew about habitability. Life, we once believed, needed warmth, light, Earth-like conditions. But as we look deeper into our own solar system, and far beyond, it becomes clear that life might thrive in the shadows, in oceans without skies, in worlds whose suns have long since dimmed. Barnard's star is not a place of comfort. It is a place of mystery. It dares us to expand our definitions, to break free of Earth's narrow perspective. It asks a simple, haunting question. What if life out there looks nothing like life down here? There's more. Barnard's star is moving toward us. In the astronomical future, it will glide past the solar system at a distance of just 3.8 light-years, offering the closest stellar encounter for the next 33,000 years. That may sound like a long time, but in cosmic terms, it's practically tomorrow. It is, therefore, a priority target for interstellar exploration. If the breakthrough Starshot project succeeds in sending nanocraft to Proxima Centauri, Barnard's star may be next. Its tranquility makes it a stable laboratory in the sky. Its proximity makes it accessible. Its age makes it wise. Imagine the first probe arriving there, piercing its starlight, gliding past its frozen super-Earth, listening for magnetic fields, for spectral signs, for heat in the ice. Imagine finding something, not civilization, not noise, but complexity, chemistry, possibility. What would it mean to find even microbial life, thriving in a world 10 billion years old? It would shatter our loneliness. It would break the silence of the void. It would tell us that life is not an accident, but a pattern. And in that moment, Barnard's star would become more than just a faint dot on a star chart. It would become a mirror, because ultimately, the real journey is not just to other stars. It's inward, toward understanding, toward humility, toward the profound truth that we are part of a universe, not just of light but of time. Barnard's star burns quietly now, as it has for billions of years. It will continue to burn for trillions more, long after the sun is gone, long after Earth is dust. It will still be there, whispering across the dark, holding secrets in its ice. A silent sentinel, a palifier, waiting. What if the brightest star in our sky is not a beacon of life, but the graveyard of a solar system that never had a chance? There's a star that has haunted the human imagination since we first looked skyward. The ancients called it the Scorcher, the Burning One. Dogs howled at its rise. Pharaohs aligned their temples to it. Cultures across millennia treated it as a harbinger of floods, of fire, of fevered omens. It is Sirius, the brightest star in the night sky. To the naked eye, it gleams as a single diamond. But like most things in the universe, its brilliance hides a secret. Sirius is not one star, but two, and one of them is already dead. At just 8.6 light-years away, Sirius is one of our closest stellar neighbors. Its brilliance isn't a matter of proximity alone, it's truly a massive powerhouse. Sirius A, the dominant of the pair, is a blue-white star twice the mass of our Sun and 70% larger in diameter. Its surface sizzles at 10,000 Kelvin, making it 25 times more luminous than our golden anchor. But it doesn't shine alone. Orbiting it, dim and difficult to detect, is Sirius B, a white dwarf, the smoldering corpse of a once mighty star. They orbit one another like past and future, like life and entropy, locked in a 50-year gravitational waltz. Their separation swings wide up to 30 astronomical units, yet they remain chained by invisible threads of gravity. To stare at Sirius is to see two destinies, one just beginning to burn bright, and one already collapsed into silence. Sirius B is strange, only 6,000 kilometers wide, barely larger than Earth, but weighing nearly as much as the Sun. Its density is unfathomable. A teaspoon of its material would weigh millions of tons. Its surface glows at an incredible 25,000 Kelvin, but its light is weak. It is a candle beside a searchlight. And yet, it wasn't always this way. Roughly 120 million years ago, Sirius B was the dominant star, a massive, blue-white titan. But stars that burn bright die young. It exhausted its fuel, ballooned into a red giant, and then shed its outer layers in a final, magnificent burst, destroying everything in its system. The protoplanetary disk that may have once cradled baby worlds was vaporized. Planets in progress, if they existed, were incinerated, scattered, or consumed. What remains is a stellar ghost, circling its once younger companion. Now Sirius A is the dominant force, but its fate is sealed. In time, it too will die. The light of Sirius is the light of two funerals, unfolding on different timescales, one already mourned, the other waiting. It gets stranger. Despite extensive searches, no planets have been confirmed in the Sirius system. None. Not even dust rings. Not even debris. Why? Some say it's because the system is too young, not enough time for worlds to form. Others argue it's too violent, that when Sirius B went supernova, its fury obliterated everything. Or maybe the very geometry of the system hides any planets from our view angled just so that they don't transit their star from our perspective. But there's a more chilling hypothesis, that any worlds which did form were simply lost, scorched by ultraviolet radiation, destabilized by gravitational shifts, or swallowed whole during Sirius B's expansion into a red giant. That long ago, a silent solar system bloomed here, only to be erased. We may never know. The Sirius system is a mystery wrapped in blue fire and white ash, a system that hints at the fragility of worlds, at how thin the line between creation and destruction truly island. And yet, the story isn't over. Sirius A is growing brighter every year. In 60,000 years, it will be even closer to Earth, just 7.5 light-years away, dominating our night sky with unparalleled brilliance. It will outshine every star we've ever known, casting shadows at midnight. But brightness can be a death cry in disguise. In about 660 million years, Sirius A2 will burn through its nuclear fuel. It will expand, redden, swell with unstable power, and in that moment a thermonuclear tantrum. Its luminosity will spike thousands of times over. Then, just as suddenly, it will collapse. Another white dwarf, another ghost. A system once bathed in light, reduced to two cinders, circling one another in silence. No planets, no warmth, just memory. But even in this, there is beauty, because the death of a star is not just an ending, it's a beginning. The shock waves, the radiation, the ejected elements, gold, uranium, oxygen, they will drift into the interstellar void. They will become dust, and that dust will become new stars, new planets, new chances, maybe even us someday. There's a poetic cruelty in this cosmic recycling. The star that destroys might also one day create. The system that failed to nurture life might, in its death, plant the seeds for a billion others. We are all made from stardust, they say. But some stars give more than others. Some stars are wombs, others are wombs. Sirius is both. And still, we gaze at it. We wish upon it. We chart ships by it. We name our dogs after it. We are drawn to it not just for its light, but for what it represents. Power, legacy, fate. It is a system living in both the past and the future. It reminds us that brightness doesn't mean safety, that even the most luminous stars carry shadows, that somewhere, even now, worlds are being born and destroyed in the very same breath. Look at Sirius. Let it remind you. Every light in the night sky is a story. Some are still being written, others are already over. What if the most promising Earth-like planet is just a mirage close enough to seduce our hopes, but built on the edge of a silent furnace? There is a star so dim you cannot see it with your eyes, a red ghost drifting 14 light-years away, flickering gently at the edge of the local interstellar cloud. It offers no warmth to our night sky, no radiance to beckon telescopes from rooftops, and yet it may be home to the most tantalizing collection of alien worlds we've ever found. This is Wolf 1061, a small, cool, unassuming red dwarf. It burns at a temperature of just 3,272 Kelvin, about half as hot as our Sunday. Its radius is barely 30% that of Sol, and its brightness? A faint whisper, only 1.1% of the Sun's output. But it is what orbits Wolf 1061 that captures our imagination. 3 rocky exoplanets, 3 potential harbors of life, and one of them might be in the sweet spot. We begin with Wolf 1061b, the innermost world. This is a place that knows no dusk, no dawn. It orbits so tightly that a year lasts only 5 Earth days. At a distance of just 0.038 AU, the planet is tidally locked, forever showing one face to its parent star, like a candle pressed to a furnace, melting on one side, frozen on the other. Its mass is roughly 1.5 to 2 times that of Earth. Its radius, about 20% larger. From above, it might look familiar, a round blue-green marble drifting in darkness. But up close, it's a nightmare. Flares from the parent star pummel the planet constantly. Stellar winds whip the thin or non-existent atmosphere into submission. The day side scorches, the night side freezes, and any notion of life of shelter evaporates into the void. Wolf 1061b is not a home. It is a warning. A siren planet beautiful from afar, lethal up close. Next comes Wolf 1061c, the crown jewel of the system. This is the world that made scientists lean forward in their chairs. Located within the habitable zone, at 0.089 AU, Wolf 1061c completes a full orbit every 18 days. Its mass? About 3 to 4 times that of Earth, a super-Earth. Its radius? 1.6 Earths. Its surface gravity? 60% stronger than our own. A heavier step, a deeper breath, a more demanding environment, but possibly survivable. It receives less solar energy than Earth, resulting in an equilibrium temperature of -50 degrees Celsius colder than Mars. And yet, with the right conditions, a thick atmosphere, greenhouse gases, internal geothermal heat, it might host liquid water, oceans beneath thin ice, valleys of mist, maybe even storms and seasons. And so, humanity wonders, could this be our sister world? But before we let hope run wild, we must confront the paradox. Habitability is not a location. It's a delicate balancing act, a symphony of dozens of variables, each one crucial. And Wolf 1061c plays that symphony on a broken piano. The planet's high surface gravity may trap a dense atmosphere thicker than Venus, suffocating, crushing. A greenhouse effect too strong could turn the planet into a steam-laden inferno, or worse, a lifeless world locked in stasis, where air circulates poorly, where radiation from the red dwarf strips ozone from the skies, allowing deadly ultraviolet waves to pierce straight to the surface. It's not enough to lie in the habitable zone. The term itself is a mirage, a seduction of terminology. Life does not sprout simply because a planet sits at the right distance. It depends on chemistry, on magnetism, on climate stability, on chance. Wolf 1061c may be on the razor's edge, or it may be already dead. And then there's Wolf 1061d, the farthest and the most enigmatic. This world follows an elongated, eccentric orbit, swinging between 0.21 AU and 0.73 AU, a celestial pendulum tracing an elliptical dance through light and shadow. It completes a full orbit every 217 Earth days, caught in a seasonal loop far more extreme than anything we know. Its mass is approximately 7.7 Earths, bordering between rocky super-Earth and gaseous mini-Neptune. Its radius, depending on composition, might lie anywhere from 1.7 to 2.2 Earths. And despite its range, it never enters the habitable zone. It is almost certainly uninhabitable. And yet, it holds scientific gold, because this world, with its shifting seasons and distant chill, might tell us how planets evolve when their stars are stingy with warmth. It could offer insight into atmospheric erosion, surface chemistry, internal heating, and the slow, long death of once lively worlds. Wolf 1061 is perched at the fringe of the local interstellar cloud, a wisp of superheated hydrogen through which our solar system currently drifts. This cloud is thin, far thinner than the vacuum of space on average. Its temperature, set, 0 Kelvin. Its density, barely 0.3 atoms per cubic centimeter. Our solar system has been gliding through it for 10,000 years. In another 2,000, we'll exit into a region even thinner, hotter, more alien. Alpha Centauri has already passed into the next cloud, the G cloud. We are straddling the edge. And Wolf 1061? It is a sentinel on this boundary. This makes the system scientifically invaluable. Its location, planetary diversity, and low stellar luminosity create a perfect lab to study the edge of habitability and the borderlands of galactic neighborhoods. It is a bridge between where we are and where we might go. What makes Wolf 1061 remarkable is not its luminosity, its beauty, or even its promise of life. It is its uncertainty. It teeters between extremes light and dark, heat and cold, possibility and ruin. It reminds us that our search for life is not just a science, it is a philosophy. We do not seek warm planets. We seek meaning. We project our own longing for survival, for belonging, for hope onto these distant stars. We want Wolf 1061c to be habitable because we want a mirror, another blue world, another chance. But the cosmos owes us no such comfort. What it offers instead is complexity. Maybe that's enough. Maybe standing on the shores of possibility, staring into the red haze of a dying star, wondering if beneath that crimson light something breathes, is the most human thing we can do. Wolf 1061 doesn't give us answers. It gives us the right to ask. What if the most Earth-like planet in the galaxy doesn't have skies or continents but a single, endless ocean, and beneath it, no light, no wind, just pressure, heat, and the possibility of life waiting in darkness? There are worlds that scream with fury, lava planets, gas giants, shattered moons locked in tidal violence. And then there are those that whisper, 42 light-years from Earth, orbiting a dim red star called GJ 1214, drifts a quiet enigma, a planet that doesn't shine, doesn't flare, doesn't call attention to itself. Yet it may be one of the most extraordinary objects ever discovered. Its name is GJ 1214b, and it may be the first true ocean planet we've ever seen. Let's start with its size. This exoplanet is about 2.5 times the diameter of Earth and around 6.5 times as massive, a chunky super-Earth, floating close to its small parent star. Its orbit is blisteringly tight, just 0.014 AU, a distance 75 times closer than Earth is to the Sunday. It races around GJ 1214 inches, just 36 hours, locked in a perpetual gravitational embrace. Its surface temperature, anywhere between 120 degrees Celsius and 280 degrees Celsius, a range that spans from scalding to truly apocalyptic. It depends on the reflectivity of its atmosphere, an atmosphere we still haven't pierced fully with certainty. But here's what we do know. GJ 1214b is not made like Earth. Its density is too low, around 1,870 kilograms per cubic meter, far lighter than a rocky planet of its mass should be. This tells us something profound. GJ 1214b is likely made of 75% water and 25% rock. Imagine that. An entire world made of ocean. Not oceans on a planet, oceans as the planet. But this is not water as we know it. This isn't a warm Caribbean Sea or an Antarctic iceberg. This is a planet with an ocean over 100 kilometers deep. That's nearly 10 times the depth of Earth's Mariana Trench. The pressure at the bottom would reach 20,000 atmospheres, a force so intense it compresses water into exotic forms of ice, such as Ice 7, a solid denser than liquid water that remains frozen even at thousands of degrees. Imagine that, ice that's heavier than water, sitting at the bottom of an ocean of superheated liquid, and beneath that, a rocky metallic core trapped, isolated, surrounded by a cryosphere of pressure ice, thousands of kilometers thick. This isn't just a planet, it's a sealed tomb of silence or a cradle, depending on what hides beneath. Above the ocean lies an atmosphere cloaked in mystery. Because GJ 1214b transits its star from our vantage point, scientists have been able to use spectroscopy to examine the starlight that passes through its upper atmosphere. But the data is confusing. We expected to find water vapor, hydrogen, helium, or perhaps methane. Instead, we found ambiguity, a flat, featureless spectrum, as if the atmosphere is hiding its own composition. Some suspect a thick layer of clouds or haze, made from hydrocarbon particles similar to Titan's smog-like veil. Others think the atmosphere is simply too dense for current instruments to penetrate. It is as though the planet does not want to be understood. Still, we theorize, given the temperature range, the entire planet may function like a giant steam boiler, its atmosphere in thermodynamic equilibrium with the ocean below. At the surface, water vapor is as dense as liquid. The distinction between ocean and sky dissolves. There is no surface, just a continuous gradient of heat, pressure, and density until finally, at the planet's heart, lies silence. A pressure so great not even water can remain liquid. A floor of crystalline ice. A heat trapped from formation, still radiating outward. And the question, could life exist here? That's where science pauses and poetry begins. Because conventional wisdom says no. Life as we know it needs not just water but chemistry, microelements, nutrients, geological cycling. Ocean planets like GJ 1214b may lack all of this. No continents, no plate tectonics, no volcanic upwelling, no contact between ocean and rock, just endless water, sterile, closed. But maybe life doesn't need continents. Maybe there are forms we haven't yet imagined, pressure-tolerant, element mining, abyssal creatures, drawing energy not from sun or sulfur, but from chemical gradients we haven't studied. And if life evolved here, it would be ancient, quiet, hidden, not broadcasting, not signaling, just being. It wouldn't build radios or cities. It would just survive. NASA's 2020 models suggest that planets like GJ 1214b might be common, billions of them, scattered across the galaxy. Cold ones with oceans under ice. Hot ones like this where steam, heat, and gravity blur the boundary between sea and sky. It may be that most habitable worlds are not Earth-like at all. They are ocean worlds, alien, closed, undetectable except as shadows. And this changes everything. We've been pointing telescopes at distant stars looking for blue marbles, for Earth's twin. But perhaps we've been missing the real diversity of life-supporting planets because they don't resemble us. The universe may be full of water, and yet empty of comfort. GJ 1214b is no paradise. Its seas are unbroken by land, its storms never stop, its gravity is heavy, its pressure immense, its skies are boiling, metallic and opaque. There is no horizon, no dawn, just variations in fog and fury. But it is real, and perhaps more importantly, it is possible. And possibility is the fuel of every voyage. It is why we explore, why we build ships out of light, why we aim them toward darkness and hope something whispers back. Even if it sounds like boiling water behind a wall of cloud, there's a final mystery here. If GJ 1214b's atmosphere is so thick, why haven't we detected the usual suspects? Hydrogen, helium, methane, water. Some speculate that the outer layers have sealed in the core that the planet's past is frozen beneath. inaccessible. Others suggest that exotic chemistry is at play, that elements we haven't yet considered are absorbing or blocking the spectral lines. And still others wonder, is this even a planet as we define it? Or is it something else? A proto-world, never fully formed? A failed Neptune, stripped of its gas? A cosmic riddle, wrapped in cloud, floating in the slow red light of a forgotten sun? For now, we don't know. All we know is that beneath the silence, beneath the haze and pressure and fire, there lies water. And wherever there is water, there is hope. What happens when a star exhales its final breath, not in silence, but in a storm of fire, dust, and memory? Far beyond the familiar planets and the hopeful exoplanets, past the quiet suns and frozen oceans, there is a place where death burns bright. It lies 650 light-years away, in a forgotten pocket of space, a star, swollen with age and trembling at the edge of collapse, a red colossus, pulsing with light that took centuries to reach us. Its name is CW Leonis, also known as IRC +10216, and it is dying. But this death is not still. It is magnificent, violent, transformative. It is not just the end of a star, it is the birth of legacy. CW Leonis is what astronomers call a carbon-rich red giant, a swollen elder of the stellar family, nearing the end of its evolutionary arc. Once, long ago, it may have been a bright blue-white star, not so different from our sun in its youth, but larger, faster burning, and more short-lived. Now, it has become something else entirely. At its pulsation peak, CW Leonis reaches 560 times the sun's radius, so vast that if it replaced our star, it would swallow everything from Mercury to Mars. Even the asteroid belt would shiver beneath its outer layers. And yet, despite this incredible size, it isn't particularly massive, just 1.5 to 4 solar masses. That's because its interior is hollowing out. The thermonuclear engines within are flickering, burning fuel unevenly, cycling between collapse and rebirth. This star is unstable, its outer layers swelling and contracting in a slow, rhythmic agony. Its pulse? Every 649 days, the luminosity of CW Leonis swells by over 11,000 times, then fades, then swells again. It's breathing, in fire. But what truly sets CW Leonis apart is not just its size or brightness. It is the cloud it is creating, a massive, spiraling shroud of gas, dust, and elements, cast off by the star itself. Every year, this dying giant sheds 4 times 10 to the power of 22 tons of matter, a mass comparable to Earth, lost in a solar wind of ash and memory. Over time, this stellar exhalation has built an immense circumstellar nebula, stretching 84,000 astronomical units wide. That's nearly a light-year across a celestial veil spun from the star's own fading body. And within this cloud, we've detected more than 70 unique chemical compounds: carbon dioxide, ammonia, water vapor, even complex organics. This is more than a stellar death. It is alchemy. There is poetry in this process. As the star pulses, it casts off rings and arcs, like ripples in time, each one a relic of a previous cycle, frozen in the vacuum. The nebula is filled with bulges, jets, spirals, and chaotic clumps, sculpted by stellar winds and perhaps something else. Because here's the mystery: CW Leonis might not be alone. In 1994, and again in 2017, astronomers noticed subtle shifts, distortions in the star's orbit, asymmetric ejections, strange patterns in the dust cloud. It suggests the presence of a companion, a faint red dwarf or brown dwarf, orbiting unseen, disturbing the star's dying breath. But it hides too well. Its light, if any, is lost in the dust. It moves like a ghost within the fog, perhaps 100 years per orbit, shaping the nebula with invisible hand. This companion may be real, or it may be an illusion, just like so much of what we see in the death of stars. And yet, even as CW Leonis fades, it gives us one final surprise: water. There is a surprisingly high concentration of water vapor in the star's upper layers, far more than should be possible. According to standard stellar evolution models, all the oxygen near the surface should have long ago fused into carbon monoxide. No water should remain. So where is it coming from? At first, astronomers thought maybe icy comets or outer system bodies were falling inward and vaporizing, but the temperatures didn't match. Then, in 2009, a new hypothesis emerged. The star's own surface may be tearing open. Massive ruptures, temporary windows through which ultraviolet radiation escapes, could create local regions hot enough to break apart molecules of silicon oxide and carbon. The freed oxygen then bonds with hydrogen, forming water vapor where none should exist. If this is true, CW Leonis isn't just dying, it's raging. Soon, in astronomical terms, the end will come. In 10,000 to 30,000 years, CW Leonis will burn through the last of its helium, lose structural cohesion and collapse. But it won't go quietly. It will explode not in a supernova, but in a gentle, final exhalation. Its outer layers will peel away, forming a glowing planetary nebula, while its core collapses into a white dwarf, glowing at millions of degrees. And then, it will begin its eternal fade, a journey from white to black, from heat to shadow, from star to ghost. It may take billions of years, but one day, CW Leonis will become a black dwarf, cold, invisible, indistinguishable from the void. Its story finished, or so we think, because even in death, this star will give life. The shockwave of its collapse will forge new elements: uranium, gold, lead. These atoms will drift into space, seed dust clouds, be pulled into new stars, new planets, new biospheres. Some of them may form bones or brains. Some may become part of you, and in that way, CW Leonis will never truly die. It will become a story told again and again in the flesh of future civilizations. What stuns us about this star is not just its grandeur, but its fragility. For all its mass, its heat, its fury, CW Leonis is delicate, a bubble of nuclear pressure held in balance by gravity and time. It only takes a shift, a bit of instability for it to unravel, and yet, it chooses to unravel beautifully, not as destruction but as creation. So the next time you look up at the night sky and wonder about those faint flickering stars, remember CW Leonis, a red giant dying in slow motion, carving nebulae from its own body, writing the future in ash and light, and whispering, in every breath of gas it exhales, I am becoming. What if the sky's brightest lights were not singular sentinels, but vast cosmic ballets, stars orbiting stars, shadows tracing shadows, bound together in gravitational dance too intricate for our eyes to see? Look toward the constellation Gemini. There, glimmering in the cold tapestry of night, lies a star you may know by name, Castor. To the naked eye, it's a crisp white beacon, the second brightest light in Gemini, outshone only by Pollux, its mythological twin. But here's the deception. Castor isn't a star, it's six, a stellar hall of mirrors, orbiting, spiraling, and colliding in a gravitational dance choreographed across millions of years. A family of light, not unlike our own solar system, but infinitely more complex, more volatile, more alive. This is not a place of simplicity. This is a stellar maze. At the heart of Castor lie its two brightest players, Castor A and Castor B. From Earth, they appear as a single, luminous point. But when observed through even modest telescopes, they resolve into a tight binary two blue-white stars, both more massive and hotter than our Sunday. They orbit one another at a distance of roughly 110 astronomical units, completing one revolution every 445 years. Each of these twins burns with the light of youth, hot, fast, brilliant, but each is also not alone, because both Castor A and Castor B are themselves binary systems. Yes, two binary stars, orbiting each other, each pair spinning around a common center of mass, each pair locked in its own fast, intimate waltz, its components completing revolutions in mere days. The gravitational tides must be immense, dragging at atmospheres, inducing flares, twisting magnetospheres. And then, circling around them from afar, like a quiet observer comes the third system, Castor C. At first glance, Castor C is the faint cousin, dim, red, easily overlooked. But here's the twist. Castor C is also a binary red dwarf system, two low-mass stars, barely a fraction of our Sun's mass, locked in a passionate, rapid orbit, less than 20 hours per revolution. They're so close, their surfaces may be brushing. Their tidal bulges stretch them like teardrops. These stars don't orbit so much as embrace forever, circling one another in heat and friction. The Castor C pair orbits the AB system at a distance of about 1000 AU, completing a full circuit every thousands of years. And in this grand dance, Castor becomes not just a binary, not even a triple, but a sextuple system, a six-star labyrinth, and we've barely begun to understand what that means. Can planets exist in such a chaotic place? Could worlds find stability in the crossfire of six suns? According to some simulations, yes. If they form close to individual stars, tightly bound within their respective gravitational wells, planets might survive. They would orbit just one partner, sheltered from the turbulence of the others. These would be close-in planets, likely tidally locked, scorched by flares and radiation. But if a planet were to orbit farther out, trying to embrace two or more stars, it would likely be torn apart, shredded by conflicting gravitational pulls, or flung into interstellar exile. And yet, evidence suggests that something is lurking out there. In 2018, astronomers observed a strange quirk in Castor C's orbit, a rhythmic variation, a wobble that shouldn't be there. It hinted at a massive object influencing the binary's motion, distorting the timing of their dance. Not a star, not a comet, something in between. A brown dwarf, perhaps an object too big to be a planet, too small to sustain fusion, or maybe something else. If there are planets in the Castor system, they are likely to be unlike anything we've seen, sculpted by six sources of gravity, bathed in a symphony of starlight. Imagine standing on such a world. On one side of the sky, two crimson suns spin endlessly, painting your nights in blood red. On the other, distant and blinding, a pair of white giants flash and pulse, casting razor-sharp shadows across a rugged, barren land. And above it all, a sky filled with motion stars, orbiting stars, constellations warping in real time. A world where midnight never come, only phases of brightness, only variations of chaos. There's something deeper here than just astrophysical marvel, because Castor is not just a curiosity, it's a warning, a system of such intricate balance, such precarious harmony, that it teeters on the edge of collapse. One misstep, one supernova, one orbital disturbance, and the dance could unravel. And yet it has endured, for millions, perhaps billions of years. How? Because nature finds balance in places we expect only disarray. Because gravity, when given time, becomes choreography. Because the cosmos, in all its violence, sometimes composes symphonies of motion. There's also a metaphor here hidden in the light. To the ancient world, Castor was the mortal twin of Gemini. His brother, Pollux, was divine immortal, untouchable. But Castor, he bled, he died, he burned brightly, and vanished. And so Zeus placed them both in the sky, together forever, in motion, immortality through memory. Now look up. That myth has become astronomy. Castor the mortal is in truth a family of stars, each bound to the others in gravitational memory, burning in cycles, dying in pairs, reborn in light. Immortality through gravity, immortality through motion. And what about us? What does a six-star system teach us so far from Earth? Perhaps that complexity does not preclude life, that beauty can emerge from chaos, that balance can be found where none should exist, and perhaps most importantly that we too are part of such a dance. Our atoms were forged in stars like these. Our world moves in orbits carved by gravity, time, and ancient collisions. We are Castor. We are the children of stellar complexity. So the next time you gaze into the sky and see what looks like a single star, remember this. Behind that light may be a dozen lives. Behind that calm, a cosmic storm. And behind that brightness, the echo of 1,000 orbits still unfolding across time. What if the emptiness around us is not silence, but memory? What if space isn't empty at all, but filled with the ghosts of stars that once screamed their final breath into the cosmos? We float inside a void, but this void is not nothing. It's called the local bubble, a vast egg-shaped cavity of low-density gas stretching roughly 300 light-years across. And it is here, in this nearly silent vacuum, that our sun has wandered for the past 5 to 10 million years. But the local bubble was not always silent. It was forged in fire. To understand the local bubble, you must picture the interstellar medium not as empty space but as a sea of gas and dust, gently waving between the stars. This medium is thick enough to scatter starlight and birth new suns. It's the raw womb of the cosmos. But sometimes, that calm is shattered. A supernova, the death of a massive star, erupts into this medium, releasing a wave of energy that carves out a hollow. The explosion acts like a fist punched into fog, scattering, compressing, sweeping clean. Over time, multiple supernovae can create overlapping voids, forming what astronomers call a bubble. That is what we are in now. Our sun is traveling through the aftershock of at least 15 nearby supernovae explosions that occurred over the past 10 to 20 million years. Long before human eyes ever opened, these stars died violently, and their deaths cleared out the region we now call home. We didn't start inside the local bubble. Our solar system entered it slowly, quietly, as if crossing the threshold of an ancient cathedral filled with ash and echoes. For most of its history, the sun was swimming through a denser region of the galaxy, but roughly 5 million years ago, it slipped into this void. Since then, we've been sailing through it like a boat adrift in a cosmic graveyard. Yet this graveyard is not cold. It glows faintly. The gas inside the local bubble is still hot, estimated to be over 1 million degrees Kelvin, though incredibly thin. It's a plasma, ionized and ghost-like, shimmering faintly in X-rays. It is as if we are sailing through the embers of a long-dead fire. And here's where the paradox arrives. We are in the safest place in the galaxy, because others have died here. The supernovae that created this bubble might have obliterated any life nearby. But the aftermath, this hollow, is less hostile than the surrounding medium. Fewer dense molecular clouds to collide with, fewer cosmic rays, more stability. Like flowers that bloom from volcanic soil, Earth may have thrived inside this silence carved by stellar screams. And here's another layer. The very atoms that make up your body, iron, calcium, oxygen, may have been forged in those very supernovae that hollowed this space. The ghosts outside are not strangers. They are family. As our sun continues its 2.25 million year orbit around the galactic center, it will not stay in the local bubble forever. Already, it is nearing the rim, brushing against a denser, cooler cloud called the local interstellar cloud. We are on the edge of change. The next few tens of thousands of years blinks, in cosmic time, may see our system pushed out of this hot silence and into new terrain. The density of gas and dust will increase. The heliosphere, the protective bubble blown by the solar wind, may shrink. Cosmic rays might increase. Climate might shift. The Earth might feel, ever so slightly, the difference in its galactic neighborhood. It's like moving from a quiet valley into a bustling city, except the city is filled with radiation and what caused the supernovae that built this place. We trace them back to a moving group of young stars called the Scorpius-Centaurus OB Association. These were massive stars, burning fast and dying young. Some were 10, 20, even 30 times the mass of our Sunday. As they aged and exploded, each supernova added its fire to the growing cavity, sweeping the interstellar medium outward. Shells of gas compressed along the edges, places where new stars may be forming even now. Destruction becoming creation, silence breeding song. And if we could hear the echoes of those explosions, they would not be sound but light, heavy elements, dust. They would whisper, "I was once a star. I burned bright, I died, and from my death, I made room for you. This is the rhythm of the galaxy. Life does not arise in the quiet, but in the wake of violence. It is the peace after the fire that makes consciousness possible. We do not merely live in the aftermath. We are the aftermath. So often we imagine space as empty, as cold, but the local bubble tells us otherwise. It is not emptiness. It is a footprint left by the dying steps of ancient titans. It is an invisible monument to impermanence, a temple built by pressure waves and plasma, now housing our fragile civilization. Even our radio waves, as they flee Earth, must pass through this veil of firelight memory. They carry our voices across the remains of stars, and maybe someday they'll reach a world orbiting a sun that has yet to explode, and a voice will be heard in the silence. We were here, we wondered, we listened. You are not outside the story. You are in it. You breathe air that came from stars that exploded here. You are built of calcium and iron that once shook the heavens. You are a thought that could only form in a region like this, emptied by death, stabilized by time, illuminated by X-ray whispers. We look for meaning in sacred texts, in dreams, in patterns. But sometimes, meaning is just a bubble, a silence, a hollow left behind by fire. What happens when the fabric of reality folds in on itself? When time and space are no longer separate threads, but collapse into a single scream, silent, invisible, eternal. There is a monster at the center of our Milky Way, but it does not roar, it does not move with menace, or breathe fire, or bare its teeth in the night sky. It waits, in silence, in shadow, in the constellation of Sagittarius, 26,500 light-years from Earth. There exists an object so dense, so gravitationally monstrous, that it warps time itself. We call it Sagittarius A times the supermassive black hole at the center of our galaxy. It has the mass of over 4 million suns, yet it fits inside a region smaller than the orbit of Mercury. Let that sink in. 4 million stars, crushed into a single point, and still, we cannot see it, because Sagittarius A times is cloaked in perfect darkness. But how do we know it's there? Because space itself tells on it. Like a whirlpool in a river, the stars around Sagittarius A times orbit with impossible speed. Some, like the famous star S2, whip around it at 7,650 kilometers per second, completing a full orbit in just 16 years. These orbits aren't gentle ellipses, they are slingshot arcs, dramatic curves bent by a force that defies understanding. It's like watching leaves circle a drain that shouldn't exist. And at the center? Nothing. No light, no form, no solid surface. Just a gravitational hunger so intense that everything matter, light, time falls inward and never returns. This is what we call a singularity, a place where the known laws of physics cease to function, a place where our equations go blind, a place where reality breaks. Black holes are strange enough, but supermassive black holes, like Sagittarius A times, are cosmic juggernauts. They don't form from collapsing stars like ordinary black holes. No, they are born from a deeper riddle. Where did they come from? Did they form first, seeding the galaxies around them? Or were they born from galaxy cores collapsing inward over eons? We don't know, but we do know this. Every large galaxy has one, and without them, galaxies like ours may not exist at all. Here's the paradox. Sagittarius A times is a destroyer. It tears stars apart, it swallows light, it devours information, but it is also an anchor. It holds the Milky Way together. Without this invisible heart, the galaxy would unravel, stars would drift, spiral arms would dissolve. We might not be here. In death, it gives structure. In darkness, it provides order. It is both predator and pillar, chaos and necessity. But Sagittarius A times is not always silent. Sometimes it feeds, not often. It is currently dormant, a sleeping dragon, but occasionally it stirs. A cloud of gas wanders too close. A star brushes the event horizon. And when that happens, the space around it lights up like a beacon. X-rays, gamma rays, gravitational waves. It's not the black hole itself we see, it's the screams of the falling. The radiation emitted as matter is stretched and shredded into a glowing halo before vanishing forever. In 2019, for the first time, we caught a glimpse of this violence. The Event Horizon Telescope captured the shadow of a black hole in another galaxy, M87. Soon after, scientists turned their eyes toward Sagittarius A, and though it was fainter, messier, harder to see, we saw it. We saw the outline of the unseeable. We glimpsed the edge of nothing. Imagine it, a dark sphere, not glowing, not shining, but defined by absence, a hole punched into the universe, where space collapses inward and time slows to a crawl. To stand near Sagittarius A times would be to fall forever. Time for you would stretch infinitely. The outside world would race forward, centuries passing in seconds. To you, it would feel like a moment. To the rest of the galaxy, you would vanish. You would become memory. And yet in this darkness, there is beauty. Because black holes are not just holes. They are storytellers. They reveal the structure of reality. They confirm Einstein's general relativity. They twist light, bend time, and map the boundaries of what's possible. Some theorists even suggest they hold gateways to other universes, to other dimensions, to mirror realities folded into the quantum foam. We don't know, but when you gaze toward the center of our galaxy, past the dust, past the stars, past the illusions, you are looking at something that is both death and dream, a cosmic sphinx, a puzzle that eats answers. There is poetry here, that in the heart of the Milky Way, where we once imagined a heaven, there lies a gravitational well so deep that even light bows to it, that the core of our existence is not a throne but a void, and yet we orbit it, we build around it, we survive because of it. The universe is not sentimental, but it is, in some strange way, aware. It folds beauty into paradox, like origami made of stars. And here, in the silence of Sagittarius A, we glimpse a truth. Not all monsters destroy. Some hold everything together. How do you describe something you've never seen? A shape so vast we live inside it, blind to its full design. What does our galaxy look like from the outside? And what does that say about us? From Earth, the Milky Way is a ribbon across the night sky, a foggy band of starlight, a whisper of infinity. But this is only a sliver of the truth. The Milky Way is not just a blur of stars. It is a colossal spiral, a gravitational whirlpool made of 400 billion stars, countless planets, clouds of gas, dark matter scaffolding, and a black hole anchoring its core. But how do we know this? We've never left the galaxy. We cannot step outside and snap a photograph of our celestial home. We are trapped inside it, like ants trying to draw a cathedral from the inside. Yet, through patience, inference, and light itself, we've begun to reconstruct its shape. The Milky Way is a barred spiral galaxy about 100,000 light-years across and 1,000 light-years thick. Think of it as a pancake with a swirling center, a dense, luminous bulge flanked by curved spiral arms like galactic rivers frozen in time. But it isn't flat. No, the Milky Way warps. Its disk is twisted like a vinyl record left too long in the sundae. This galactic warp is likely caused by interactions with smaller galaxies, like the Large and Small Magellanic Clouds, which tug and stretch the Milky Way's edges like celestial puppeteers. Even the spiral arms, so elegant in diagrams, are not perfectly defined. They're messy, disjointed, sometimes flaring with starbirth, sometimes fading into interstellar fog. Our galaxy is both a structure and a story, and that story is written in its arms. There are 4 main spiral arms: Perseus arm, Norma arm, Scutum Centaurus arm, Sagittarius arm, but tucked between them are smaller segments and spurs, twisting off like broken branches of a cosmic tree. We live in one of these spurs, the Orion, Cygnus arm. It's not the grandest, not the densest, but it's home. From here, we orbit the galactic center at about 828,000 kilometers per hour, taking 225 million years to complete one circuit. That means Earth has only circled the galaxy about 20 times since it was born. Think of that. In the age of dinosaurs, Earth was on the opposite side of the galaxy. As continents moved, so did our position in the Milky Way spiral. Our world doesn't just spin, it dances through a gravitational spiral, a journey woven into deep time. But there's more to the shape than arms. Above and below the disk is the stellar halo, a faint spherical cloud of ancient stars, some 13 billion years old. These stars don't orbit in neat circles. They plunge in and out of the disk like icy comets, reminders of a more chaotic era. And farther still lies the dark matter halo, invisible, massive, and mysterious. This dark halo holds our galaxy together like scaffolding. Without it, the Milky Way would fly apart, the stars spinning too fast to be held by gravity alone. We can't see this dark matter, but we can feel it. It shapes the curves of the spiral. It bends the paths of stars. It is the unseen architect of the galaxy's form. Like memory shaping personality, dark matter shapes structure silently, invisibly, yet undeniably. The shape of the Milky Way isn't just a physical feature, it's a timeline. Where the spiral arms bloom with blue stars, we know new life is forming. These stars are hot, short-lived, like cosmic fireworks marking nurseries of planetary birth. Between the arms, where stars are older and redder, we see the past, the ancient record of what came before. The galactic bulge at the center, that's the eldest of all. The stars here are ancient, crowded, chaotic, a stellar city packed with history and mystery, orbiting that silent black hole we now know. So, as we trace the spiral arms, we trace time itself from the fiery now to the echoing then. Here's the poetry. A spiral is both expansion and return. It reaches out and loops back in. Galaxies spiral not because it's efficient, but because it's beautiful. The universe is under no obligation to be aesthetically pleasing yet again and again. It chooses curves, arcs, and elegance. Why? Some say it's mathematics, others say it's physics, but maybe it's reflection. Maybe the spiral is a signature of systems that learn, grow, remember, like neural networks, like hurricanes, like galaxies, like us. We spiral through time, through thoughts, through stories that circle back to where they began, only to begin again. And yet, in all our reconstructions of the Milky Way, our maps, our diagrams, our simulations, we've never actually seen it from the outside. We are embedded in it. We cannot look upon our home the way others might. It's like trying to see your own eyes without a mirror. But maybe that's the point. Maybe the Milky Way isn't something to observe from afar, but something to feel from within. A journey we're still taking, a shape we're still becoming. We are not outside observers. We are spiral born. We are the children of a curve drawn in starlight, moving through a story still unfolding. What happens when two giants meet in the dark? Do they pass like strangers in the night, or devour each other like ancient gods reclaiming the stars? From our peaceful perch in the Orion Arm, it's easy to imagine the Milky Way as calm, stable, eternal. But beneath the harmony of stars lies an ancient appetite. Galaxies eat each other, and the Milky Way is no exception. It has feasted on its neighbors for billions of years, not in bursts of savagery, but in slow gravitational hunger. This cosmic cannibalism is written into the very structure of our galaxy. Look closely, and you'll find the bones of former galaxies embedded in our halo, strands of stars stretched across the sky like celestial scars, remnants of long-digested civilizations. These are the ghost rivers, streams of stars torn from smaller galaxies, now coiling through the Milky Way like memories that refuse to fade. One such victim was the Sagittarius dwarf galaxy, discovered in 1994. It was small, ancient, and doomed. As it passed too close to our galaxy, the Milky Way's gravity tore it apart. Star by star, it was shredded, until only a whisper of its core remained, a distorted relic still spiraling through our halo today. But Sagittarius is not alone. Other galaxies, Ursa Minor, Sextans, Carina, Fornax, Sculptor, all bear the mark of encounters with our galaxy's gravitational jaws. In the darkness, the Milky Way grows fatter, not by creating stars, but by consuming them. This process is not a glitch. It is how galaxies evolve. We are the result of such collisions, a layer being made from the remains of others. Even our stellar halo, that ghostly sphere surrounding the disk, may be a mosaic of hundreds of minor galaxies long forgotten. Their stars now roam freely, no longer bound by the gravity that once defined them. And yet, in this destruction, something new is born. Collisions between galaxies ignite starbursts, waves of creation, where clouds of gas collapse into stars at staggering rates. The death of one structure gives birth to millions of suns. From consumption comes creation. This is the paradox of galactic violence. It destroys and it builds. But the Milky Way's greatest feast still lies ahead. In about 4 billion years, we will collide with our nearest large neighbor, the Andromeda Galaxy. Right now, Andromeda is rushing toward us at 110 kilometers per second, an inevitable convergence that will reshape both galaxies forever. This is not science fiction, it's celestial destiny. When they meet, the stars themselves will almost certainly not collide. The distances between them are too vast, but the gravitational chaos will twist both galaxies into surreal shapes. Their spiral arms will distort, their central bulges will swell. Long tidal tails of stars will stretch into space like wings of flame. Eventually, after multiple passes and hundreds of millions of years, the Milky Way and Andromeda will merge into a single, larger galaxy. Scientists already have a name for it, Milkomeda. It will be massive, elliptical, older, and we, or whatever remnants of us remain, will be part of its foundation. But what happens to Earth? If it still exists by then, Earth will likely survive the collision, physically intact. The Sun may get flung into a new orbit farther out, perhaps into the galactic outskirts. The night sky would be transformed. Imagine looking up to see Andromeda's core swelling, like a second moon, a glowing tidal bloom that dwarfs the Milky Way's faint band. Then, as the galaxies spiral together, new stars would light the sky, the heavens alight with fireworks of cosmic fusion. It would be both terrifying and sublime, a front-row seat to a celestial apocalypse that births a new galactic age. But the real danger won't be from the collision. By then, the Sun itself will be nearing the end of its life, swelling into a red giant, burning away Earth's atmosphere, boiling the oceans. The real extinction comes not from galactic violence, but from the timing of stars. So why does the universe build with destruction? Because gravity knows no mercy. It only knows motion, mass, and inevitability. Galaxies collide because they must, because the fabric of space-time draws them together, because there is no path that leads away only toward the embrace of annihilation. And in that embrace, galaxies do not die, they transform. Like caterpillars cocooned in gravitational silk, they emerge in new forms, larger, more complex, more beautiful. Galactic cannibalism is not a horror, it's alchemy. It is how the universe writes new scripts from broken fragments. There is something deeply human in this story. We too absorb others, their stories, their languages, their traumas. We carry the memory of wars, migrations, fusions of culture and blood. The human mind is a psychic Milky Way, shaped by collisions. What if galaxies are minds? What if the Milky Way is a memory palace, each star a neuron, each collision a trauma that reshapes its identity? What if these collisions aren't just mechanical accidents, but steps in a greater narrative of becoming? We will never know, but the parallels are haunting. In the end, we are made not only from the stars, but from the galaxies they devoured. And someday, our stars will be part of a new cathedral born of destruction, lit by rebirth. What if the emptiness around us isn't just empty, but a record of violence? What if we're living inside a scar the galaxy never forgot? We orbit a gentle star within a swirling arm of the Milky Way, surrounded by tens of thousands of other suns. But between us and many of them lies something strange. Nothing. A vast region of low-density gas and dust. A cosmic cavity. This is not normal. Stars are born in dense clouds of molecular gas nurseries, packed with raw material. Yet here, in the region where our solar system resides, the interstellar medium is eerily thin. It's like waking up in a house, only to realize it stands inside the burnt ruins of a forest fire. This region is known as the local bubble, a vast spherical void roughly 1,000 light-years across, with the sun near its center. It isn't smooth. It's irregular, lumpy, and bordered by denser, colder gas, like a balloon half-torn, floating through the galactic plane. For decades, astronomers wondered, what carved this emptiness? What force evacuated matter from this region of the galaxy? The answer is explosive. About 10 to 15 million years ago, a series of supernovae ripped through this part of the Milky Way titanic stellar deaths, each one unleashing more energy in seconds than the sun will emit in its entire lifetime. These weren't isolated events. They came in waves. Massive stars from a now vanished stellar association lived fast and died young, collapsing under their own gravity and detonating as brilliant cosmic bombs. Their combined shockwaves swept up the surrounding gas and dust, pushing it outward like a plow across a snowfield, creating an expanding shell. This shell became the local bubble, and we, our sun, our Earth, our everything are inside it. The Earth itself formed after the explosions quieted, drifting into the bubble as the solar system orbited the galaxy. So we were not here for the violence, but we now live in its afterglow. You are breathing stardust inside a wound. This bubble has real consequences. Because of the lack of dense material in our region, new star formation is minimal near us. We are not in a stellar nursery. We are in the aftermath of fire. Even the dust between us and the stars is thinner here, making our view of the cosmos unusually clear. This clarity helped astronomers build early star maps, measure distances, and observe galaxies far beyond the Milky Way. Ironically, we understand the universe better because we live in a region where a part of it was blown away, and yet the bubble is not empty. Within it, we find traces of those ancient explosions, isotopes like iron 60 embedded in deep-sea sediments on Earth, suggesting that supernova dust reached our planet. Imagine atomic relics of cosmic death drifting through space, falling through Earth's atmosphere, landing in the ocean, and eventually being discovered millions of years later by creatures evolved inside the very scar that birthed them. That's us. Our planet is a fossil record of galactic trauma. Even now, the bubble is not stable. It's expanding, morphing, interacting with other bubbles. The Milky Way is filled with such cavities, remnants of other supernovae, regions shaped by stellar winds and radiation. These bubbles overlap, collide, and merge, forming a foam-like structure in the interstellar medium. The galaxy is not smooth, it's pitted with history. We now believe that the sun is on the verge of exiting the local bubble. Just beyond its edge lies the G-cloud, a denser interstellar region we may enter in the next few thousand years. And as the solar system punches through this boundary, we will be reborn into a thicker cosmos with new dust, new gas, and potentially new radiation pressures. The cosmic weather is about to change. We are migratory passengers, traveling from void to density. So what does this mean for us? It means that even emptiness has a story. The silence between the stars is not just passive. It's a memory, a silence earned through fire, a canvas cleared by cataclysm. We live inside the ghost of ancient suns. And just like the rings of a tree carry the story of seasons, the shape and chemistry of the local bubble carry the narrative of violence, decay, and aftermath. There is something sacred in this. We often seek meaning in presence, in what is seen, what is built, what survives. But here, meaning lies in the absence, in what was taken away, in what once raged and now no longer exists. And perhaps that's a lesson for us as a species. We too leave scars. We burn, we collide, we destroy, and sometimes we forget that emptiness is not erasure, it is memory. The void remembers. The sky is full of absences. What if the spaces we flee, the silences in our lives, are not failures, but wounds that once held fire? What if healing doesn't mean returning to what was, but learning to live gracefully in what remains? We do not live in the center of the galaxy or the heart of starbirth. We live in a scar, a remnant, a hollow echo, and somehow, from within this silence, consciousness emerged to ask why it was born in a wound. What if the galaxy you see isn't the galaxy that is? Every star you've ever wished upon, every nebula painted across a telescope's eye, every radiant spiral captured by the Hubble lens, all of it is just a glimmer on the surface, a shimmering illusion atop something far larger and far more mysterious. Because what truly holds the Milky Way together isn't made of stars, it isn't made of planets, it isn't even made of atoms. What binds our galaxy into its majestic spiral form is something we cannot see, cannot touch, cannot even define completely. We call it dark matter, but that's just a name for our ignorance. Here's the paradox. If you tally up every single visible object in the galaxy, stars, planets, gas, dust, black holes, you name it, it still only accounts for about 1015% of the mass required to explain the Milky Way's behavior. So how is it even spinning? It shouldn't be. The outer stars are rotating far too fast. According to Newtonian physics, they should have been flung off into the void long ago, like children flung from a merry-go-round spun too quickly. But they remain, bound, suspended, as if held by ghostly arms wrapped around the galactic disk. This is how we first discovered the need for dark matter, by watching how galaxies moved and realizing that something unseen must be holding the cosmos together. Something with gravity, but no light. Something massive but silent. An invisible scaffolding that extends beyond every glowing spiral, surrounding galaxies like halos, stretching like connective tissue between clusters, forming a cosmic web. In the Milky Way, dark matter forms a vast spherical halo much larger than the galactic disk. Picture a glowing frisbee, our spiral arms, embedded within a massive, invisible fog that extends for hundreds of thousands of light years in every direction. We are not flying through empty space. We are swimming in shadow. This dark halo provides the gravitational glue that holds our stars in orbit. Without it, the Milky Way would unravel in cosmic seconds. The stars would scatter, the spiral would collapse. But they don't, because the invisible skeleton holds. What is dark matter made of? We don't know. It is not baryonic, not made of atoms like us. It doesn't emit, reflect, or absorb electromagnetic radiation, so it can't be seen directly. It doesn't clump like gas. It doesn't form planets or suns. It's like gravity without substance. Possibilities? Hypothetical particles like WIMPs, weakly interacting massive particles, axions, sterile neutrinos, but decades of experiments, underground detectors, particle accelerators, telescopes, scanning the sky for gravitational lensing, have yet to find a single direct piece of evidence. This is not just a scientific problem, it's a cosmic insult. How can we not know what most of the universe is made of? Still, we do see its fingerprints. Gravitational lensing, when light from distant galaxies is bent and warped by invisible mass, reveals the shadow puppetry of dark matter at work. In galaxy clusters, we see more lensing than visible mass can account for. It's as if entire galaxies are marionettes, pulled by invisible strings. We are beginning to map the dark skeleton, not by seeing it, but by seeing how it shapes what can be seen. That's the paradox of dark matter. It is the most honest kind of mystery. It changes everything, even as it reveals nothing. Philosophically, it's a humbling realization. What if most of reality lies outside the visible? What if truth is not what glows, but what governs the glow? What if the universe is not a stage, but a shadow play, and we are simply watching silhouettes dance? Dark matter teaches us something uncomfortable, that light can lie, that presence can be deceptive, that the most important forces in existence may not be flashy or hot or burning with radiation, but silent, cold, and unseen. And isn't that true of life too? The foundations of our psyche, memories, fears, dreams, longings aren't visible either, but they shape us. What if the cosmos has a soul, And what if dark matter is its subconscious, unspoken, buried deep, impossible to measure, but always present? There's more. Dark matter isn't the end of the unknown, because even dark matter can't account for all the mysteries we see. The universe is not just held together strangely, it is also expanding strangely, and that leads us to something even more bizarre. Dark energy, a force that isn't holding the cosmos together, but pushing it apart. Together, dark matter and dark energy account for 95% of the total mass energy of the universe. That means everything we've ever studied, every experiment, every planet, every star, every law of physics tested in laboratories applies to just 5% of reality. We are children playing in a candlelit corner of a cathedral whose walls we cannot see. And yet, despite all this, despite being blindfolded in the dark halls of reality, we are mapping the walls. We are chasing shadows with reason. We are building telescopes to see gravity's fingerprint. We are crafting theories to make sense of the unseen, not because it's easy, but because it's in us, because we too are the universe. And somewhere in our atoms, perhaps even in our dreams, the dark remembers. The Milky Way is not just made of stars, it is a skeleton of shadow, a galaxy built on ghosts. We are the children of gravity, held not by light, but by something we cannot name. At the center of everything lies a paradox, a hole that weighs more than suns, a silence that screams. Every whirl has a heart, every spiral a source. And at the center of the Milky Way, beneath a veil of gas and dust 26,000 light-years from Earth, sits an object so strange, so massive, and so utterly silent that it distorts space, time, and imagination alike. It's not a star, it's not a planet, it's not even a thing in the way we understand things. It is a black hole, a supermassive one. Its name is Sagittarius A, but names cannot contain it. This monster weighs in at over 4 million times the mass of our Sunday, and yet it occupies a space no larger than the orbit of Mercury. Imagine stuffing a mountain into a pinhead. Now multiply that absurdity a few million times. You still won't be close, because Sagittarius A times is not made of matter as we know it. It is what remains when matter collapses into pure gravity, a singularity, a point of infinite density, where the laws of physics cease to function, surrounded by an event horizon, a boundary from which nothing, not even light, can escape. A one-way door to oblivion. How do we know it's there? We've never seen it directly, not until recently, but for decades, we've watched the stars near the center of our galaxy, and something has kept them dancing in tight, ferocious orbits. Star S2, for instance, orbits Sagittarius A times every 16 years at speeds up to 7,600 kilometers per second, faster than any known planet, faster than any man-made craft. Only one kind of entity could exert that kind of gravitational grip, a supermassive black hole. In 2022, the Event Horizon Telescope gave us the first actual image of Sagittarius A times, or more precisely, its shadow, a glowing, swirling ring of matter devoured just before the fall, bent and warped by gravity. It was like staring into the pupil of the galaxy. But Sagittarius A times isn't just a monstrous object, it's also a cosmic metaphor. The very idea of a black hole pushes our minds to the limit, a place where time slows to a stop, where the fabric of reality folds back on itself, where cause and effect dissolve. A black hole is not an object, it's an absence. Not a star, but a scar on space-time. And yet, from that scar emerges order. Galaxies orbit them, stars are born around them. Cosmic architecture seems to obey their invisible influence. So the question arises, is the black hole a destroyer or a creator, a devourer or a seed? What lies beyond the event horizon? This may be the most profound question in physics and philosophy. Some say nothing, a sheer collapse into singularity, where matter and information vanish. Others say everything, that black holes may be gateways to other universes, connected by hypothetical tunnels called wormholes. Others still believe in holography, the idea that what falls into a black hole isn't lost, but encoded on its surface. like a cosmic USB drive. Even Stephen Hawking wrestled with this puzzle until his final days. Can information be destroyed? The stakes of this question touch the very foundation of reality, because if information can truly vanish, then so can meaning, memory, and causality itself. But let's step back. Here we are, on a tiny blue world in the Orion arm of the Milky Way, and 26,000 light-years away, something monstrous waits at the core. And yet, we feel nothing. We go about our days. We sip coffee. We fall in love. Meanwhile, that black hole anchors the galaxy, bends space-time, and governs stellar orbits like a hidden king. And that's the strange poetry of it. The galaxy is a dance, choreographed by something silent, invisible, and merciless. What kind of universe is this, where the most massive things are the quietest, where the brightest stars die in darkness, where the center is a void, and the void holds everything together? Sagittarius A times also poses a strange psychological mirror. It forces us to ask, what lies at the center of me? Am I just a surface of memories orbiting an unknown core? Is there something in me I can never see, but which anchors my being? Something massive, something silent, something no thought can escape? Perhaps we too carry our own singularities, deep wells of grief, love, or longing that distort everything around them, and just like the galaxy, we build lives around them. One day far in the future, our sun will die, Earth will be long gone, the spiral arms will drift and fade, but Sagittarius A times will still be there, devouring, waiting, anchoring what remains. And perhaps, when the stars are all gone, only black holes will remain the final sentinels of existence, cosmic memories, echoes of what once was. And in those last moments, the black holes might whisper secrets back to the universe, secrets we were never meant to hear. The center of the Milky Way is not a sun, but a wound. And yet from that wound comes form, orbit, order, and awe. Perhaps the most important things in the universe are not seen, but felt, not known, but sensed. At the center of gravity lies a mystery that weighs on us all. In the end, the journey through the stars was never just about the stars. It was about us, and what we become when we remember where we truly are. Imagine for a moment that you are floating in space, not near Earth, not even near the Sunday, but far out beyond the dust lanes, past the spiral arms, on the outskirts of the galaxy itself. Behind you stretches the entire Milky Way, a glowing river of light, a wheel of 400 billion stars, a great cosmic city suspended in blackness. And you are just one small consciousness, drifting. From this vantage point, everything changes. Here, the illusion of separation dissolves. You are not outside the galaxy. You are of it. The calcium in your bones, the iron in your blood, the oxygen you breathe, all forged in the furnace of dying stars. You are the child of supernovae, the product of billions of years of cosmic alchemy. And the galaxy? It isn't out there. It is in here, mirrored in your atoms, echoed in your neurons, remembered in the silence between heartbeats. You are a living piece of the Milky Way, a flash of awareness in a sea of hydrogen and gravity. But now the question must be asked. Why does the universe allow something so small to ask questions so big? Why do we yearn for understanding? Why do we look at the stars and feel longing instead of indifference? This journey wasn't just observational, it was existential, because every planet we passed, every star we admired, every nebula we painted with metaphor, they weren't just celestial objects. They were symbols. Each one reminded us of something buried deep inside. The boiling oceans of exoplanets mirrored our inner turbulence. The distant suns mimicked the passions we orbit. The black hole at the center whispered of the gravity of our grief, our purpose, our fear of the unknown. The galaxy wasn't just scenery, it was a canvas for meaning. Now, let's zoom out even further. The Milky Way is one galaxy among an estimated 2 trillion in the observable universe. And just like stars within the Milky Way, galaxies themselves cluster, spin, drift, collide, So what is the Milky Way? It is a momentary swirl in an ever-changing cosmic ocean, a pattern in the void, a breath in the lungs of the cosmos. And we, the creatures who name it, chart it, wonder about it, are the briefest sparks. So what do we do with this knowledge? Do we despair at our smallness? Or do we rejoice in the fact that the universe, through us, becomes aware of itself? The ancient mystics said, "As above, so below," and they were right more than they could ever know. The structures of our neural networks echo the filaments of galaxy clusters. The vibrations of atoms mirror the rhythms of planets. The cycles of life and death in stars, in ecosystems, in civilizations repeat the same cosmic script. And perhaps that is the greatest secret the Milky Way whispers. There is no true boundary between science and soul, between the observer and the observed, between the flesh and the stars. We will never separate. One day, the galaxy will fade, the stars will exhaust their fuel, the black holes will evaporate, entropy will silence every last flicker of light. And yet you were here, thinking, feeling, telling the story, and in doing so, you bent the arc of time even just a little toward awareness. That is not a small thing, that is everything. So what now? Now that you've danced with giants, fallen into black holes, and witnessed alien shores, you return not to Earth, but to yourself carrying the memory of stars. You look up at the night sky differently, not as a backdrop, but as a mirror, because to know the Milky Way is not to conquer it. It is to remember that you've never been apart from it. We do not belong to the universe. We are the universe, briefly aware. And so this journey ends, not with an answer, but with a silence, a knowing, a presence. And in that silence, the heartbeat of the galaxy continues. It pulses in stars, in atoms, in minds. It pulses in you. And perhaps, just perhaps, that was the purpose all along. The stars will die, the galaxies will drift, the universe will cool into silence. But this moment right here was warm, alive, conscious. In a spiral of light, you found yourself. This was your journey around the Milky Way.